In a previous video, we talked about how we can measure the distance along a circle between a starting point, point 1, and an ending point, point 2. And we did this by relating it to the circumference of the complete circle, where we said c equals 2 pi r, and we're taking that 2 pi that's in front of the r to represent the angular measure all the way around the circle. So in other words, that's the complete angle for the circle, which we know is 360 degrees. Another way of writing that is 2 pi radians. Now, thinking about that along those same lines, we can talk about sectors of a circle. Now, what I'm talking about are pie pieces, right? If you have an apple pie and you cut it into what looks like a triangular wedge, that's actually not a triangle, but it's a sector, because one edge of the outside edge is part of a circle. So we're going to calculate the area of this particular sector of the circle. Now, as you recall, the area of a circle is pi r squared. But if we want to write the area of the circle in terms of the complete angle, 2 pi, we can rewrite it like this. We can say that the area is 2 pi r squared divided by 2. Or another way of writing that still is we can say that this is 1/2 multiplied by r squared multiplied by the complete angle, 2 pi. Right? So we have 1/2 times r squared times the complete angle of the circle, which is 2 pi. So we could write this as the area of a sector is 1/2 r squared multiplied by the angle. The angle measurement is that Greek letter theta, and theta means the measure of the angle. I have some crazy neighbors. Okay, so for this particular sector, we said that the angle was pi over 4 radians. So in this case, we can measure the area of that sector, or calculate, I should say, the area of that sector by doing 1/2 r squared. Well, r is 6, so that's going to be 6 squared multiplied by the measure of the angle, but the measure of the angle not in degrees, but the measure in radians, which is pi over 4. And so if we go ahead and calculate this, we get 1/2 multiplied by 36 multiplied by pi over 4. Now we know that 4 goes into 36 9 times, so our end result here is that the area of the sector is going to be 9 over 2 multiplied by pi, and in this case that would be square centimeters. So we were able to calculate the area of that sector. Now, to compare that to the area of the complete circle, A is equal to pi r squared. Right? In this case, the radius of the circle is 6 centimeters. So if we square 6 squared is 36, and we would get 36 pi square centimeters. Now, as it happens, right, a 45 degree sector, that's 1/8 of the complete circle. Well, what that means is that if we divide 9/2 pi by 36 pi, we should get 1/8. And do we? All right, well, let's do the math. Let's pull out the calculator. So what we're going to do is, you'll notice that the pi's cancel, and then we're going to do 9 divided by 2, which is 4.5, and then we're going to divide that by 36, which is 0.125, and the question is that 1/8? Well, let's compare that. 1 divided by 8 is 0.125, so we see that 0.125 is equal to 0.125, and so therefore it checks. So we got the correct area of that sector as 9 over 2 pi square centimeters. So the thing to remember here is this formula for the area of circular sectors. So the area of a circular sector is 1/2 r squared times theta, as long as the measure of the angle is in radians. And that's an important point to remember, and we will use this in the future.